Hello, I'm Akila from CSEA. My topic is Big Data Processing Stacks. The introduction about the topic, it involves the volume, variety, velocity, and the value. It originates from web and the Internet of Things, sensor, and social media. The role of big data in decision making enables predictive and prescriptive analytics. This is about the introduction of big data analytics. The characteristics of big data. It involves the volume, massive data generation, and the velocity, where it is the real-time data inflow, and the variety involves the diverse data types like text, video, and logs, the veracity, trustworthiness of data, and the value, insights derived for strategic advantage. The big data architecture overview, modular pipeline, ingest, process and store and analyze, use of parallel and distributed computing, and the hybrid batch stream models, integration with machine learning and AI workflows. It is about the big data architecture and the overflow. What is big data stack? Collection of tools enabling end-to-end data handling, supports structured and unstructured data, includes ingestion, storage, and processing visualization, scalable to enterprise and cloud environment. This is about the big data stack, which is a collection of tools enabling end-to-end data handling, supports structured and unstructured data, includes ingestion, storage, and processing visualization, scalable to enterprise and cloud environments. Layers of a big data stack. There are 6 layers: data sources, which involves in the Internet of Things, logs, and databases. These are the data sources of big data. Ingestions, it involves Kafka and NiFi. The storage is HDFS and S3 are the storage layers of big data stack. The pre-processing or the processing involves in the Flink and the Spark, the machine learning and analytics, MLlib and TensorFlow. Visualization, Power BI and Superset are the layers of big data stack. Data ingestion tools, Kafka, publish and subscribe messaging, Flume, log aggregation, NiFi, visual flow design, Spoke, import and export, RDBMS, the relational database management system, and the CDC tools for real-time ingestion. These are the data ingestion tools. The data storage technologies, HDFS, fault tolerant file storage, and Cassandra, scalable column store, and the Amazon S3 cloud native object store, and a Delta Lake acid on data lakes, and HBase real time read and write. These are the data storage technologies of big data stack. The batch processing frameworks, Hadoop, MapReduce, traditional batch jobs, Hive, SQL abstraction over HDFS, and the big scripting for data transformation and handles petabyte scale data sets. The stream processing framework, Spark streaming, micro batching model, Flink, true real-time streaming, Shroom, the event-driven processing, the Kafka streams, lightweight stream processor. These are the stream processing frameworks of big data. The Apache Spark Unified Engine, which is also called the Unified Engine, and it supports batch streaming and ML and graphs in memory data caching, Spark SQL structured data queries, and machine learning library for machine learning workflows. This is about the Apache Spark, which supports AI, SQL and machine learning libraries to unify the engine and streaming process in memory data caching, data warehousing and query engines. The Presto and Rhino distributed SQL. These are the data warehousing and query engines of distributed SQL. The Redshift, which is a data warehousing and query engine of AWS data warehouse. The BigQuery, the serverless analytics engine. The Druid is the data warehousing of low latency online analytical processing. The data analytics and machine learning. Spark machine learning library, integrated machine learning and TensorFlow on big data, H20 AI for scalable AI models, Skitlearn for pipelines integration. These are the data analytics and machine learning tools. The workflow tools of big data analytics, Airflow, DAG based learning and OG Hadoop job scheduler, Lagi, Workflow Dependency Manager, Argo, Kubernetes native workflows. These are the workflow tools of big data processing. And next, the data visualization tools, table, drag and drop dashboards. The table which contains the combination of rows and columns where it is used for relational database management system where the data we can drag and drop dashboards, the Power BI, business intelligence tool, and the Superset, open source analytics, and Kibana, which involves in the log and metric visualization. These are the data visualization tools for the big data analytics. Let's consider the example of big data stack of Lambda architecture, which contains the layers in the architecture. It involves three layers. The first, the batch layer. Hadoop batch layer involves the Hadoop for historical data, where the second layer called the speed layer, the Spark streaming for real time, and the third layer, and it is the final layer and the bottom layer, the serving layer, NoSQL Presto for queries and combines accuracy and latency. This is about the example of Lambda architecture, which combines accuracy and latency. The cloud native big data stacks, the AWS, EMR, Glue and Redshift S3 are the cloud native big data stacks. The Azure, where it contains Synapse, Data Lake and HT Insight. The GCP, which involves BigQuery, data flow and data pre-processing. In the data pre-processing process, it involves where the data is collected from the data warehouse. It should be clean and it should be verified from the other data. So it is known as the data pre-processing, fully managed and scalable services. The challenges in big data processing, ensuring data quality, data integration from diverse sources, managing real-time pipelines, skill gap in modern tool sets. These are the challenges in big data processing. The trends and future directions for the big data processing. Rise of Lakehouse called the Delta and the Iceberg, AI-powered data engineering, federated data processing, serverless and cost-effective analytics. These are the trends and future directions for the big data processing. The conclusion about the topic, big data stacks, streamline data workflows, which involves in the big data, it is storage of large data sets to involve and to manage the data manipulation and data analysis which is better accuracy to for the classification and the prediction process, and the big data processing is very used by the machine learning algorithms for the prediction and classification purpose. Big data analytics are very useful to handle the big data stacks. It streamlines the data workflows. The tool choice depends on latency, volume, and structure. The cloud platforms democratize big data access, and the continuous learning is key for IT professional. So the cloud based and the big data processing democratize big data access and big data handling. So for big data handling, big data processing, for the big data stacks and streamlined data workflows are very important. It continuous learning is key for IT professional. Thank you.